Okay, so I got asked by someone to do a rapid five on domain issues of functions. And I will do that. I can't remember what the other ones that people asked me about because the board got erased. I'll try to remember and then do two more videos, but right now I'll just talk about domain. It's easiest to find the domain of a function by finding out what doesn't work than what does. All right, so you find out what doesn't work, and then you write what does based on the elimination of what doesn't work, and that's your domain. So let's just talk about domain in general. Domain means the sign of what I can use. Now, when we do the sine function, we start at 0 as an angle, and we just start going around and around and around and around and around again. And that's positive distance, and that doesn't seem like anything other than the good old-fashioned number line. And yes, the sine function goes between 1 and -1 forever in that direction. And there's nothing that says we couldn't have started at 0 and gone the other way. So it goes in this direction as well, sinusoid. So what's the restriction on this function? Nothing. I can take the sine of any number, find out where it is as a distance from 0 on the circumference, positive and negative direction, and I can perform a calculation. The issue is, what calculations do we have that you can't perform all numbers on? And there are three that come to mind. Maybe there's more. I can't think of anything at the moment that has a restriction other than 3 functions. Can you think of the 3 functions? The 3 mathematical operations that I'm thinking of. And again, there may be more, but it's not coming to me at the moment. If we encounter others, we'll deal with it. I think this one, I think square root's a problem. I don't think you can take the square root of -3. I don't think it's a real number. I don't think you can take the square root of negative numbers. I think you can take the square root of 0 because 0 times 0 is 0, so that works. But I don't think you can find a number times itself that gets you -3. In fact, I don't think you can take the 4th root of -3. I don't think you can find a number times a number times a number times a number. Remember, the same number, right? I don't think you can do a negative times a negative times a negative times a negative to get a negative. So even roots is a problem. Even roots are a problem. I'm just going to talk for another minute. Cube roots aren't a problem. I think you can do the cube root of -8. Yeah, -2 times -2 times -2. That exists. All right, but even roots, that's a problem. 2 other functions come to mind. Can you think of what they are? Yeah, I hope you said division. I think in class we've talked about this a lot. Can't do that. So I guess division by 0, even roots, the argument of the function. So the argument of the function, what's inside here? So for even roots, the argument of the function, we'll call it open parentheses, has to be greater than or equal to 0. Okay, so that's the domain of roots. You have to pick numbers that are bigger than or equal to 0. The domain of a division problem, the argument, I mean, of a division, I'm not quite sure how to express that. All I can tell you is division can't divide by 0. So what can we have? Some number divided by 0 equals can't do it. I guess that's how I'll communicate that to you. And there's one other function. Do you happen to know what it is? It's logarithms. And that's the argument of a log. Logs have bases that have to be positive. What has to go in there? Well, you got to think about what logarithms find. They find exponents. And really, it's all about the inverse of growth and decay. Right? So if something is out there and it's either growing or decaying, then over time, there should be something there. There should be something there. There should be something that you're looking at that's growing or decaying. So something there to me means that the number that you pick had better be greater than or equal to, oops, something is there, 0 isn't there. So you better have a number that's greater than 0. All right, so now rapid fire. What is the domain of the following function? And we'll erase that. I'll just give you one. How about I give you y equals 2 square root of 3x minus 4 plus 5. What is the domain? Again, you pause the video. I'm just going to do these 5 so that I can upload it before my next class. Well, look at that. I know my x's have to be greater than or equal to 4/3. Remember, we said the argument of an even root function has to be greater than or equal to 0. So 4/3 makes a 0. And I guess numbers bigger than that make this positive. So the domain of that function is that. That was problem 1. Problem number 2. Y equals 5 over x squared minus 6x. Let's find the domain. Well, I don't see any even roots up there. I don't see any logs up there. I do see division, and I can't divide by 0. So I guess we better figure out what makes x squared minus 6x equals 0. Looks like I can't use 0 and I can't use 6. So x cannot equal 0 or 6 is an acceptable way of writing the domain. Okay, can't use those numbers. Otherwise, the calculation would be undefined. All right. Y equals 4 log base 3 of x minus 5 plus 6. What's the domain? You pause the video, think about it. Think about what we talked about at the beginning of the video. And I hope you remember that the argument has to be what? Has to be positive. All right, logs are the inverse of growth and decay. We have to start with something in order to find the time at which we have that amount. And that's kind of what happens with logarithms from a practical standpoint. So x minus 5 has to be bigger than 0. So therefore x equals 5 is critical. And our answer is x has to be greater than 5. And that's why we start graphing logs with that vertical asymptote and we highlight the domain restriction. And this one would have been, just as a quick review, right? You could have put a 6 in and got a 6. You could have put in what? Log base 3, you could have put an 8 in and gotten 10. You take your time with that and you see that those numbers work. All right. What else we got? We got a combination of those issues. And how do you handle that when it gets more complicated? Not that anybody asks anything as complicated as the one I'm going to give you right now, but I'm asking you. All right, so how do we go after that? You pause the video, then I'm just going to show you. All right, the best way to do it is with number line work. I know that I have to be bigger than or equal to 8 for the numerator. The denominator has to be greater than, I got to get this positive, so -2 divided by 5, -2/5. I should have known that immediately. So -2/5, the only difference here is that's an open circle. Okay? And this is the kicker. 5x plus 2 can't equal 1. Because what's the ln of 1? The ln of 1 is 0, and you can't divide by 0. So I got another problem here. Did I push it up far enough to get here? Well, it's the problem that I've got. It's the problem that I got. I wish I had given you something different, because if it equals 1, then we're looking at -1/5, and that's to the left of 8. So not the best choice. Maybe I can try another one here off the fly. But what's the domain of this? It's just bigger than 8. Any number less than 8 is a real problem here, right? Because I can't plug in anything less than 8 there. And so this doesn't matter anymore, even though it was a nice conversation. I've got to be bigger than 8. Oh, I can use 8 in this case. I can throw an 8 in here. I can find the ln of 42. I don't know if you can do it, approximating. You'd have to know the ln of 7, which I don't even know. So I don't think we're going to do that. But this dictates, the numerator dictates in this case. So let me see if I can come up with something very quick here. I can. All right, so let's give you another one like that so that I can do this number line work. And that'll be our 5th one, unless I got another one over there. Nah, that's fine. This will be the last one we do. So y equals the ln of x minus 3. Oh, I want that in the denominator. So I want the square root of 9 minus x all over the ln of x minus 3. Now that's a good one. All right, what's going to work here? Actually, numbers less than or equal to 9. I hope you can see why. If you put an 8 in here, that works, right? But if you put a 10, square root of -1 is not real. It's imaginary. Okay, so that dictates the domain of the numerator. The denominator. Well, it can't be 3 anyway, right? Can't be 3 anyway because ln has to work on positives. But it can be bigger than 3. Oh, this is working out better. Yeah, I can use bigger than 3, but then again, just like the last problem, can't divide by 0. Is there a way of making the ln of x minus 3 equal to 0? Yeah, I think the inverse of ln is e to the, so e to the 0 equals x minus 3. 1 equals x minus 3. Sure looks like 4 is a problem. Because if I put 4 in here, 4 minus 3 is 1. What's the exponent you put on top of e to get 1? That's 0. I don't think you can divide by 0. So we're back here now looking at the overlap. Right? I can't pick numbers bigger than 9. So let's erase that. I can't pick numbers less than 3. Let's erase that. I can't pick 4. Looks like interval notation is the best way to write domain. So the domain is your x's, which are the numbers you can plug into this equation. And the ones you better plug in had better not be 3. Had better not be 4. But 9's okay. Those are the numbers you can use in this calculation, nothing else. All right, I got 2:08. Let's see if I can upload this in 5 minutes and post it. Then I'll do another one after my next class.